Nowadays, modern industry takes advantage of the use of radionuclides and the ionizing radiation they emit for many applications, from the inspection of industrial processes to the enhancement of the commercial value of materials. Their introduction has enabled significant technological improvements and high levels of automation in several industrial processes. The opportunity to put a radionuclide in a sealed containers has enabled industrial users to isolate it from the environment and allowed for the possibility of using it as a sealed radioactive source. For example, such radioactive sources are used in gauging systems that helps quality and process control. By detecting the radiation emitted by a suitable radioactive source that is passed through a material or scattered by it, it is possible to determine parameters such as the thickness, the density, and the integrity of a specimen. These checks can be implemented on production lines for continuous monitoring or used in portable devices. The continuous monitoring enables users to quickly adjust the quality and specification of products during the manufacturing process. These gauges are called nucleonic gauges or nucleonic control systems. Such gauges are a non-destructive and non-contact technique that allows preservation of the material. They are all based on proven technology that has been in use for decades. The general principle of operation of nucleonic gauges is the attenuation of the signals received with respect to the emitted signals. They are used, for example, in those industries that produce plates, sheets and coatings made of different materials, such as paper or metals, and need to measure the thickness with high precision. Although today's efforts are directed towards the creation of new devices that use UV radiation or X-rays, nucleonic gauges still have some advantages. In metals applications, one of the advantages lies in the fact that nucleonic gauges are not adversely affected by dust, scale, and oil mist. They can be used when metals are dirty, oily, covered with scale, or have a large pass line oscillations. Furthermore, the thickness measurement is continuous, with high speed, without contact, accurate, and reliable. Other uses of nucleonic gauges include the determination of the filling level in drums containing liquids. Furthermore, several portable devices have been developed and have found applications in civil construction and the petroleum industry. In the oil and gas industry, nucleonic gauges are used in particular to support well logging, a fast technique which is able to provide data on geological formations for the exploration of mineral resources. Another widely spread industrial application that takes advantage of radionuclides and ionizing radiation is industrial radiography. It is a non-destructive technique used to detect defects in objects without altering them. When we go at the airport, for example, luggage as well as people are scanned. But don't worry, it is not dangerous. Indeed, very low dose X-rays are used in full body scanners. In the case of industry, when higher energies are needed, gamma radiation from iridium-192 or cobalt-60 sources allows for penetration of thicker materials. When scientists realized the capability of ionizing radiation to induce chemical and physical changes in matter, they started to study their effects. In some cases, these changes damage the material and its properties. In some other cases, these changes led to the enhancement of the feature of the irradiated material. This enabled the development of industrial applications where materials' property can be modified by radiation to produce innovative material for high-tech applications. This is the case of polymers. This technology started to be applied on polymers nearly 60 years ago. Ionizing radiation, such as gamma rays, X-rays, or energetic electrons, has been used to modify polymers by altering their properties, allowing for a new range of applications. Polymers are macromolecules. They are constituted of long chains made of repeating units. Polymers range from synthetic plastics such as polystyrene to natural biopolymers such as silk, wool and cellulose, as well as DNA and proteins. Consequently, their large molecular mass in relatively small molecular compounds produces unique physical properties, hardness, viscoelasticity, and the tendency to form glasses and semi-crystalline structures. There are different phenomena that can be initiated by radiation. The most important chemical changes are cross-linking and degradation. Through cross-linking, radiation creates new bonds between different chains. Through degradation, radiation breaks them, thus making the chain's length shorter. Both processes alter the structure of the polymer and its properties. This phenomena can be effectively exploited to improve the usefulness and the value of commercial products, and by taking advantage of the predominance of one or the other, different results can be obtained. Cross-linking by radiation is used to produce high-performance wires and cables for insulation. It improves heat tolerance and resistance to abrasion. It is used to produce heat-shrink products for telecom and power applications or films for packaging. It allows the synthesis of hydrogels, obtaining high water concentration and increased elasticity. Hydrogel wound dressing enable wounds or burns to heal faster than with other medications. Cross-linking is exploited in a specific treatment to apply coatings to surfaces. It is used to increase the adhesion of inks or also to functionalize surface, altering the wettability. Cross-linking can also be obtained chemically, thanks to the use of additives. However, among the advantages of using radiation, there are lower cost, higher speed, lower temperatures, reduction of chemical residue, and in some cases, better material properties too. The opposite of cross-linking, chain scissioning, is used to enhance processing characteristics. On Teflon to be used as filler, on polypropylene to enhance melt flow characteristics, allowing alternative means of molding. We can find a lot of examples of radiation polymer processing in the objects we usually use every day, to cook, to take care of our health, to protect food, and so on. In the optic industry, an anti-reflective coating is applied to improve the efficiency of the lens. In an eyeglass lens, it reduces eye strain, improves vision, and makes the wearer eye more visible to the others. Radiation cure, solvent-free coatings and inks are used for magazines, newspapers, and a variety of packaging materials. This method can utilize less expensive and less reactive materials and do not require costly initiators. Radionuclides and ionizing radiation can be very useful to industry. The presence of experts is necessary to manage the sources used in nucleonic gauges or to control the radiation processes to modify polymers. Of course, the use of radioactive sources or ionizing radiation in industrial plants requires the adoption of suitable measures to protect workers' health and the environment from radiation risk.